Exercise 7.5.
Question number 16. Integral 1 divided by x into x power n plus 1 dx. We can use partial fraction method only when the factors in the denominator are either linear factors or quadratic factors. For other degree, for cubic factors, for 4th degree, 5th degree, power n, we don't know how to use partial fraction method. For other degrees, that is, other than linear factors and quadratic factors, we cannot use partial fraction method. So let us multiply both numerator and denominator by x power n minus 1. The numerator becomes x power n minus 1. The denominator x into x power n minus 1 will become x raised to n into x raised to n plus 1 dx. And now we know that differential of x power n gives us x power n minus 1 term. Therefore, let us substitute x raised to n as t. Differentiate both sides. X power n minus 1 dx becomes dt by n. Therefore, the numerator is dt divided by n. N is a constant. Let us write it outside. The denominator becomes t into t plus 1. Now we can use partial fraction method because both are linear factors. We can write this into partial fraction as a divided by t and b divided by t plus 1. The LCM is t times t plus 1. A times t plus 1 plus b times t. Equate the numerators because already the denominators are same. Let us substitute values to find the values of a and b. I am substituting t as 0. A is 1. Let us take t as minus 1. B value is minus 1. So the given question can be written in this form into partial fractions. Therefore, the given integral 1 divided by x into x raised to n plus 1 dx is equal to 1 by n times a divided by 1 divided by t and b is minus 1 divided by t plus 1 dt. Let us integrate and write 1 by n times integral of 1 by t is log of absolute value of t and integral of the second term is log of absolute value of t plus 1 and plus c. Log a minus log b is log a by b. And substitute for t. Therefore, the answer is 1 by n log of absolute value of x raised to n divided by x raised to n plus 1 plus c. The same method is applicable for question number 20 and 23. The other method to do this 16th question is 1 divided by x times x power n plus 1 dx. Let us take x power n out from that bracket. We get 1 plus 1 divided by x power n dx. It becomes 1 divided by x power n plus 1 into 1 plus 1 by x power n dx. Now we know that differential of 1 by x power n gives 1 by x power n plus 1. So let us substitute 1 plus 1 by x power n as t. Differential of 1 is 0 and here we get minus n x power minus n minus 1 dx is equal to dt, which is minus, therefore dx divided by x power n plus 1 is equal to dt divided by minus n. Let us substitute. No need to use partial fraction method here. We have dx divided by x power n plus 1, which becomes dt divided by minus n, and this term becomes t. See how easy it is? Log of t, log of absolute value of t. Therefore the answer is minus 1 by n log of 1 plus 1 by x power n plus c. We got the same answer. By taking LCM and writing the reciprocal, you can make it positive. So it is same as the previous answer. Let us do those two questions and then we will come back to 17th question. Question 20. We are going to use the same method as the 16th question. We can completely factorize that x power 4 minus 1 and do by partial fraction method, but that is a longer method. The method which we used for the 16th question is easier for this. So let us multiply both numerator and the denominator by x cube. Therefore, we get integral x cube divided by x power 4 times x power 4 minus 1 dx. Now we have x cube dx in the numerator and x power 4 in the denominator. Therefore, let us take x power 4 as t, because differential of x power 4 gives us 4x cube term. And x cube dx is dt divided by 4. The numerator becomes dt divided by 4. 4 is a constant, so I wrote it outside. And this is t into t minus 1. It is easy to split it into partial fraction. Let us use partial fraction method for this. Or the other method is you may open the brackets and use completion of squares method also. A by t plus b by t minus 1. Take LCM. Equate the numerators. Let us take the value for t as 0. We get a value as minus 1. Now let t be 1. B value is 1. Therefore, the given integral is equal to, there is 1 by 4 outside, don't forget that. And let us split this into partial fraction and write it in this form. A is minus 1 by t and b value is 1, so 1 by t minus 1 dt. Let us integrate. 1 by 4, this is minus log of absolute value of t plus log of absolute value of t minus 1. And this is log a by b. Substitute for t. 1 by 4 log of t is x power 4. And plus c.
The second method which we used for question 16 was much easier. The proof was shorter. So let us use the same method for the 20th question.
Integral 1 divided by x into x power 4 minus 1 dx. we have three methods. We can factorize this as x minus 1, x plus 1 and x square plus 1. Already we have x. We will have 4 partial fractions, and this has ax plus b form, which is going to be a very long method. So don't use this method. The other method is you can multiply both numerator and denominator by x cube and do it. But easier than these two methods is take x power 4 out from this bracket. We get 1 divided by x power 5 into 1 minus 1 by x power 4 dx. Now substitute this bracket as t. 1 minus, this is x power minus 4. Let us differentiate. Differential of 1 is 0 minus minus 4. Minus of minus 4 is plus 4. X power minus 4 minus 1 is minus 5 dx is equal to dt. Dx by x power 5 is dt divided by 4. See how simple the question has become. Integral. We have dx divided by x power 5, which becomes dt divided by 4, and that bracket is t. So easy the integration is in this case. So log of absolute value of t plus c. Substitute for t, which is 1 minus 1 by x power 4 plus c. If you want, you can take LCM and write it, otherwise leave it in this form. X power 4 minus 1 divided by x power 4 plus c. This method is the simplest of all. Let us use the same method for 23rd question. Integral dx divided by x into x square plus 1. One method is directly taking partial fraction, bx plus c by x square plus 1. Or the other method is we can multiply both numerator and denominator by x and do it. Or the easier one is we will follow the same method. We will take x square out from this bracket. We get dx by x cube into 1 plus 1 by x square, and differential of 1 by x square gives you 1 by x cube term. Let us substitute this bracket as t. Differentiate. Therefore dx divided by x cube is dt divided by minus 2. So dx by x cube becomes dt divided by minus 2. Let me write minus 2 outside the integral. And that bracket becomes t. So easy it is. Within no time you can complete the proof. Minus half log of absolute value of 1 plus 1 by x square. Leave it in this form, or you may take LCM and write it as x square plus 1 divided by x square plus c. And we know that these are positive terms, so we can remove the absolute value sign and plus c. The answer for the 23rd question is A. Now question number 17. Integral cos x divided by 1 minus sin x into 2 minus sin x dx. we have sine function in the denominator and cos x dx in the numerator. So let us substitute sine x as t, because differentiation will become cos x dx, which is dt. The numerator becomes dt. The denominator is 1 minus t multiplied by 2 minus t. Let me change the sign in both the terms. T minus 1 into t minus 2. You may use partial fraction method or completing the squares method. So let us use completing the squares method for this question. Let us multiply t square minus 1t minus 2t is minus 3t and plus 2. Integral dt divided by t minus, divide the coefficient of t by 2. Complete the squares. We don't want b square term, so subtract that b square term. 3 by 2 the whole square is 9 by 4 and plus 2. Let us simplify minus 9 by 4 plus 2. It is minus 1 by 4. Minus 1 by 4 can be written as half square. Now use the formula of 1 by x square minus a square dx, which is 1 by 2a log of absolute value of x minus a divided by x plus a plus c. Therefore, the answer is 1 by 2a. A is half log of absolute value of x minus a divided by x is t minus 3 by 2. T minus 3 by 2 plus half plus c. Take LCM and substitute for t. So 2t. T is sin x. So 2 sin x minus 3 minus 1 will become minus 4 divided by 2 sin x minus 3 plus 1 will become minus 2. We can cancel 2 throughout. It becomes sin x minus 2 divided by sin x minus 1 plus c. Because of the absolute value sign, we may write it as 2 minus sin x by 1 minus sin x also. Question number 18. It is an important question. Put a star in your textbook. X square plus 1 into x square plus 2 divided by x square plus 3 into x square plus 4. The degree of the numerator is 4. Degree of the denominator is also 4. The degrees are same. So it is an improper fraction. Since it is an improper rational function, we have to divide. Do the long division and write it as quotient plus remainder by divisor. So to do the division, we have to multiply. X power 4, 1x square plus 2x square is 3x square and 2. Here x power 4, 3x square plus 4x square is 7x square and plus 12. Write the numerator and the divisor is x power 4 plus 7x square plus 12. It goes one time. Change the sign. These two are getting cancelled. Minus 4x square and minus 10. That's it. The degree of the remainder is lesser than the degree of the divisor. So stop here and write it as quotient plus remainder by divisor. Therefore, this expression is equal to quotient is 1, Remainder is, I can remove negative sign out. So 4x square plus 10 divided by, this is the divisor. The divisor can be factorized as x square plus 3 into x square plus 4. That is the given denominator. Now this can be done by partial fraction method. Let us take that fraction 4x square plus 10 divided by x square plus 3 times x square plus 4. If you notice, in this expression we have only x square term, no x term. Here there is no x term. So if there is no x term, we can take it as a by x square plus 3 plus b by x square plus 4. No need to take ax plus b and cx plus d. Even if you take, the coefficients of x term will be zeros. So to show that, let us take x square as p. This substitution is to show that we can take it as a by b by, not for integration.
That's why I am using letter P, only for partial fractions.
So it becomes 4p plus 10 divided by p plus 3 into p plus 4. Now we can write this as a by p plus 3 plus b by p plus 4. Take LCM. See these two and equate their numerators. Four p plus 10 is equal to a into p plus 4 plus b into p plus 3. Let p be minus 3. Minus 12 plus 10 is minus 2 equal to a into 1. So a value is minus 2. Now let us substitute p as minus 4. Minus 16 plus 10 is minus 6. B into minus 1. B value is plus 6. Therefore, integral x square plus 1 times x square plus 2 divided by x square plus 3 times x square plus 4 dx is equal to, don't forget to write that quotient which is 1. We have minus sign. A divided by p plus 3. Let us substitute for p. I told you we are not going to use p for integration. Minus 2 divided by x square plus 3 and b divided by, b is 6 divided by p plus 4. P is x square into dx. Let me write the integral separately. Integral 1 dx minus of minus plus 2 dx by x square plus root 3 the whole square minus 6 times, distribute this negative sign, x square plus 2 square. Last two terms are tan inverse formula. X 1 by a tan inverse of x by a is the formula. Here a is root 3. Same formula here. A is 2. 1 by a tan inverse of x by a and plus c. Question 19. 2x divided by x square plus 1 times x square plus 3 dx. We have x term in the numerator, so we cannot write it as a by x square plus 1, b by x square plus 3. Remember that. Therefore, we have to take it as ax plus b by x square plus 1 because x square plus 1 is a quadratic term. Similarly, this is also a quadratic term, so we have to use cx plus d. This is one method, but this is a longer method. The easier method is, we have x square term in the denominator and 2x dx in the numerator. We know that differential of x square gives us 2x term. Let us substitute x square as t. Or you may substitute x square plus 1 as t or x square plus 3 as t. Simple. X square as t we will take. 2x dx is dt. Therefore, the numerator becomes dt. The denominator is t plus 1 times t plus 3. Now, after this, again we have two methods. Either we can use partial fraction method or open the brackets, use completion of squares method. Let us use completion of squares method. T square plus 3t plus 1t is 4t plus 3. Let us complete the squares. T plus, divide the coefficient of t by 2. So 2, this is your b term. Complete the squares. Always subtract b square term, which is 2 square, and plus 3. T plus 2 the whole square minus 1 square. Use 1 by x square minus a square formula, which is 1 by 2a log of absolute value of x minus a divided by x plus a plus c. 1 by 2a. A is 1 here. Log of absolute value of t plus 2 minus 1. X is t plus 2 and t plus 2 plus 1. Substitute for t. Therefore, the answer is half into log of t is x square. X square plus 1 divided by x square plus 3 and plus c.
As x square plus 1 and x square plus 3 are positive, we need not write the absolute value sign.
Question 21. Integral 1 divided by e power x minus 1 dx. We cannot write this as log of e power x minus 1. Remember, this is not a linear function in x. This is an exponential function. So log formula is not applicable here. Let us take e power x as t, differentiate, is equal to dt, and dx is dt by e power x, and e power x is t. So dx can be written as dt by t. This becomes dt by t, and this is 1 by t minus 1. Either use partial fraction method or completion of squares method. Let us use partial fraction method in this question. Both are linear terms, so a by t plus b by t minus 1. Take LCM. And equate the numerators. Let t be 0. We get a as minus 1. Let t be 1. B is 1. Therefore, the given integral becomes, we have to write it in this form, integral minus 1 by t and plus 1 by t minus 1 dt minus log absolute value of t plus log absolute value of t minus 1. See, here we are getting two log terms which should be combined as log of a by b. Whereas if you use completion of squares method, directly we will get log of a by b form. So log a minus log b is log a by b. So it becomes log of t minus 1 divided by t plus c, and substitute for t. Log of absolute value of t is e raised to x and plus c. Twenty-second question is a very simple question. X divided by x minus 1 into x minus 2. We cannot use completion of squares method here because there is x term here. Remember, we can use completion of squares method only when the numerator is a constant. With x term in the numerator, don't use completion of squares. Let us use partial fraction method. Both are linear factors. A divided by x minus 1 plus b divided by x minus 2. Take LCM and equate the numerators. We get this equation. This is a very simple question. Let us substitute x as 1. Therefore, a is minus 1. Let x be 2. B value is 2. Therefore, the given integral becomes integral a divided by x minus 1 plus b divided by x minus 2 dx minus log of absolute value of x minus 1 plus 2 log of absolute value of x minus 2 and plus c. Let us combine these two log terms. We can take this 2 as square of this. So log of absolute value of x minus 2 the whole square, and this has a minus sign, so write it in the denominator.
Numerator has whole square, so no need to write absolute value sign for the numerator.
B option is the correct option. Now let's do example 15, very important question. Put a star for this question in your textbook. Integral 3 sine phi. Whatever the variable is given in the question, use the same variable. Divided by phi, 5 minus cos square phi minus 4 sine phi d phi. We have cos phi in the numerator. Since we have cos phi d phi, let us substitute sine phi as t. I can write this as 3 sine phi minus 2 divided by cos square can be changed to sine square, 1 minus sine square, minus 4 sine phi cos phi d phi. The function is in terms of sine and we have cos phi d phi. So let us substitute sine phi as t, differentiate both sides. Therefore, the integral becomes 3t minus 2 divided by 5 minus 1 is 4, minus of minus plus t square minus 4t, and cos phi d phi becomes dt. We have linear by quadratic. We can use 7.4 exercise method, or if you are able to factorize the denominator, we can use partial fraction method also. Here it is t minus 2 the whole square. We get a repeated factor here. Let us use partial fraction method. For repeated factor, we have to take it as a by t minus 2 and b by t minus 2 the whole square. LCM is t minus 2 the whole square. Remember, the denominator of the left hand side and the LCM should be the same. A times t minus 2 plus b. Equate the numerators. Let t be 2. 2 3s are 6. 6 minus 2, 4. First term becomes 0. B value is 4. Now substitute t as 0. Minus 2 is equal to minus 2a plus b. So 2a is, b is 4. A is 6 by 2, which is 3. Let us substitute the values of a and b in this step. Therefore, the given integral becomes integral 3 sine phi minus 2 divided by phi minus cos square phi minus 4 sine phi cos phi d phi is equal to integral a divided by t minus 2 and b divided by t minus 2 the whole square dt, which is equal to 3 times integral 1 by t minus 2 dt and plus 4 times integral t minus 2 the whole square dt. This is 3 times log of absolute value of t minus 2, and this is, we can use x power n plus 1 by n plus 1 formula. It becomes t minus 2 whole raised to, this is minus 2. So minus 1 divided by minus 1 plus c. Let us substitute for t. T is sine phi. This becomes minus 4 divided by sine phi minus 2 plus c. We know that minus 1 less than or equal to sine phi less than or equal to 1. Therefore, sine phi is lesser than 2, we know. I can write this as 3 log 2 minus sine phi and remove the absolute value sign because sine phi is always less than 2. Minus, here I can change the sign to make it positive, 2 minus sine phi. Here there is no absolute value sign. So minus sign comes out, minus and minus will become plus.